And so when you set up the experience, it was all in one JSON file. With a lot of parameters that didn't make any sense to me. And so a lot of my early onboarding was, what does KP mean? And I would Google it, and I wanted to know how it would affect federated learning. So what I did was I wanted to build a front end, but what they wanted from me is a test suite. So the first thing I did was build a PyTest suite. And after the suite was done, I did one thing that I wanted to do, which was the front end. And so there was a lot of back and forth between what I'm working with a PhD team under Dr. Reznik. And so they would come up with cool ideas, and I would program them in the Python framework they have. And so their first idea was we need a test suite. My first idea was I want front end. And then their next idea was dynamic poisoning. Because in federated learning, you can poison whatever data you're using in different ways. And so you can poison the data itself by adding noise to it, or Gaussian noise is the usual, but we also have label flipping for data. If I give you an image of a cat and I tell you all the cat images are dogs, all the dog images are birds, bird images are yes. And so what they had ahead of time was, before I joined the team, was they would get a data set and poison all of that data and then run the experiments. But what they wanted for more in-depth research that they've been publishing for the IEEE conferences was dynamic poisoning or dynamic attacks. And so in the middle of training rounds, I built a system that like, should I poison this data in this round? And if it doesn't, then it would leave the data normal. And so you can set up things like, I want 10 rounds to run. And for rounds 1 and 2, I'm gonna label flip, and then I'll go back to normal. And for rounds 6 and 7, I'll add Gaussian noise and then go back to normal. Basically, they want to see how that affects the convergence of the AI model as it's trained. And what's cool about federated learning over the regular machine learning that we know is that instead of having your AI model training with the data, you separate the data from the model that trains wholly. Each individual device or client in this case would have a model of its own that is training on its own data that it doesn't share with anyone. And the only thing that my aggregation server would get from all these different clients would be the gradients, which is the math behind each of their models. And what the central client does in federated learning is it takes all your different AI model gradients and it tries to aggregate them with some kind of algorithm, which another half of my PhD team is working on new algorithms that can detect anomalies faster. And my half, which was just the interview, we've been working on the framework itself. And so every new conference would focus on something different. You know, like, okay, we have a security conference coming up. What can we focus on in this app to write about the security up front, or dependability, or whatever the case is at the time? And so, oh yeah, so all of the federated learning stuff is very compute heavy, and I have a desktop at home that has a pretty decent graphics card. So I use CUDA and GPU training for my AI. And that was something I learned this semester, so that was a lot of fun. But we usually use weaker hardware. So like I have this live demo that you can play with the app that I built. And it basically runs the same application running through the same training simulators, but I built a front end for it, so it's easier to understand specifically all the parameters that you would put into this simulation. And so I have these little tooltips that you can hover your mouse over, like the KP. It's like, what does that actually mean? And they'll tell you, like, this is a specific thing that affects this and how it would affect your experiment. So like, this might make your thing run longer, but it's going to have better performance, or whatever the case is.
So was your part specifically to try and inject poison data and trading part in this?
Yeah, so actually all of these are mine. So I built the user front end, and I use a FastAPI, Python FastAPI for the API. And then I actually built the subprocesses. So one of the issues with their framework is if it crashed, it wouldn't actually close all of the things running, and it would eat up resources. And so what I did was, before running the simulation, I made a subprocess that runs it. And so when it closes, no matter what, it's going to stop running all this. So I made the UI, I made the FastAPI, I made the subprocess. Flower was basically the only thing that they had with a wrapper to print plots. And so, I'm sorry, these two are what they had. They had both of those set up, but most of what I did was slap the front end on, the test suite, and yeah, that's mostly.
What was the overall set of goals for the front end? So what were the set of features that they wanted to do?
So they didn't want the front end. That was one of the things I did on my own. So they wanted the test suite, and they wanted one of the dynamic attacks, is what they call it. And those were both specifically for papers that they had in the co-author on. So one of those was the test suite for a dependability conference. and the other was the dynamic attacks for a conference on metacognition, which I'm still not quite sure what metacognition is. But the other two things were just me. Like I wanted to learn, so I did the front end. My goal, though, to answer your question, was I didn't know what was going on with the parameters, and instead of just having like a markdown with all the notes on what you're saying, why don't the next people that join your team in the spring, do you want them to have to go through the same process of understanding everything, or do you want them to have? So now there's a branch with the UI where you just hover your mouse, you can run the same simulations you can on the back end. But I built in this integrated terminal that kind of copies VS Codes where you can control tick and it'll open and close. And so on my front end, you can also see what he had before, which is the terminal running the simulation. And it's interactive, so you can actually run his simulation from the front end. It's using WebSockets and message queues.
So what was your, so in terms of the things that you, so when you wrote the front end, you wanted it to be able to tell you what different parameters would do, I assume. So it's, so when you look at it, it lists, I assume, the parameters for what you use for training, then it tells you what these parameters do.
Exactly.
It gives you a set of defaults that you can use to help.
I actually have 7 different presets that I set up here because they're fast experiments, so they won't have like the convergence you would expect from the 15-hour ones.
Okay.
But they run really fast through the framework, and you can actually. One of the cool things about a front end, this was another one that slipped my mind, was it generated plots through Matplotlib. So you have static plots on a PDF. What I set up was something called Recharts. So those same plot data, you can actually guide lines and change the scale of what rounds you're looking at. And so you take all that data that you had before, and now you can interact with it. And it's like, what if I hide these 2 clients that are malicious? What does it look like? And what if I only look at rounds 1 through 7? You know, you can drag it around. But the live demo's there. There's presets at the top if you've started your simulation. So you can click any of them. They should take 2 minutes at least. But what's cool about it, all the way I set it up with Docker, is that this morning I was able to run it on this Unix cluster, and my computer was a lot faster than the RIT cluster, so that really threw me off. I was happy about my GPU because in my head, the cluster is like all the muscle. And so I was very happy with the same exact simulation on my computer running in 45 seconds as well, plus it took forever. But yeah, it's nice to have something containerized and like things. That'll also help them next semester, where they have different dependencies for different. Even the MacBook, if I have an Intel chip, there's some torch stuff I can't do versus the Mac Silicon. So just a lot of learning this semester.
Yeah. Oh, that sounds good. It sounds like you had a good time.
Yeah, I've had more fun than I've had ever programming. So I'm going for the PhD to stick around, keep learning.
Do you think your background would help you?